The joyful sounds of a newborn, clouded by a very early birth. This baby is born 3 months early. In the neonatal intensive care unit, a doctor delivers news no parent wants to hear.
There's a problem. Your baby has had a brain bleed.
Premature babies are fragile. Their systems are not equipped to cope with the outside world. It's hard for them to keep their blood pressure stable, and large fluctuations often occur. The germinal matrix, a blood-rich region of the brain, is only present in preterm infants and is vulnerable to these fluctuations. The result is a germinal matrix hemorrhage, a brain bleed. For some infants, blood enters into the lateral ventricles. This is termed an intraventricular hemorrhage, or IVH. In severe cases, the blood fills the ventricles and enlarges them, causing physical damage to the walls of the ventricles. Bleeds can also occur in other areas of the brain. The bleeding stops, but the blood leaves damage in its wake, leading to the development of hydrocephalus. Why? The blood changes the brain's environment, and components in the blood, including iron and other substances, can alter how the brain cells behave. Like the cells lining the choroid plexus, a key structure in the brain which produces the majority of cerebrospinal fluid. The reaction of these choroid plexus cells to the blood causes an increase in fluid production. At the same time, the blood can damage the ependymal layer, the cells that line the ventricles. The ependyma have little hair-like structures called cilia, which help move the fluid. The blood comes in contact with the cilia, causing them to stop moving. This slows the flow of fluid through the ventricular system. As the ependymal cells are further damaged, the CSF and blood come into direct contact with the cells critical to normal brain development. The blood continues to flow through the third and fourth ventricle, causing damage and creating blockages along the way, and then exits the ventricular system, flowing around the brain. When it reaches the arachnoid villi, a major site of CSF absorption, the blood can damage and block the structures, prohibiting CSF from being reabsorbed. The CSF is trapped, accumulating, and causing the ventricles to continue to enlarge. This growing pressure from the fluid causes the brain to be compressed and the skull to expand. These damaging effects on the brain impact brain development, learning, memory, and motor controls. The brain tries to heal itself. In some cases, the infant's own natural repair processes find a way to repair some of the damage and reestablish normal CSF flow. But for this infant, the repairs weren't enough. This baby's only treatment option is the placement of a permanent shunt to drain the trapped fluid from the brain. Without a shunt, this child would likely not survive. But a shunt is not a cure, and due to complications, children often face multiple operations in a year or over their lifetime to repair or replace the device. Some people stop counting after their 100th operation. For these parents, they're not sure what the future holds for their child. But for the scientists searching for more innovative solutions, they know there is hope, and the Hydrocephalus Association is here to help them. Together, we are finding better ways to treat and prevent post-hemorrhagic hydrocephalus. Together, we are ensuring a better future for our children.